Hey guys, this is our last day of notes. Hopefully you've already watched the Ed puzzle about balancing chemical equations. If you haven't, please go back and do that before you watch this. It'll hopefully make things make a little more sense. Alright, so we had, this is not a new word, chemical change or reaction. Okay, so those are any change where substances are changed into different substances. So we have, some substances before and then after we have something different. Remember, these can be either an element, right, one of those things right off the periodic table, or a compound made of more than one elements held together with chemical bonds. Now we have names for the stuff we start with versus the stuff we're creating in this reaction. So we call the stuff we start with, the stuff that enters the reaction, the reactants. The reactants react, right? They're the ones that go in. And the things that we make are called products. So I like to say reactants react to produce products. Okay, you can kind of remember what's what here. Quick refresh, we had this law in a previous chapter. Law of conservation of mass. Remember, conserve in science means we know that we're not making any or destroying any. We're going to have the same amount before as we have after. So, if we know what the mass of the reactants is, it has to be the same as the mass of the products. Okay, we can't have more stuff than we started with before or less. It wouldn't make any sense. All right. When we're trying to write out what happens in reactions, we use a chemical equation. Okay, and in math, when we write an equation, we have an equal sign that separates the two sides. In chemistry, we're going to use an arrow. Okay, and we're going to have a picture of this on the next page. So bear with me a little bit here. But when you get to the arrow, which we call the reaction arrow, okay, you can read it two ways. You can read it as yields or produces. And they both mean the same thing, right? Alright, so to obey the law of conservation of mass, the equation must be balanced. And again, please, if you haven't already done so, watch the Ed puzzle. So when we do this, it is an action, right? It is something that we do. We balance the reaction. And to do that, we say, seems like we need more than one of this substance or a few of this substance. And we use numbers out in front that we call coefficients. Okay, just like in math, if you wrote in math 2x, that number is called a coefficient, and it is saying I have 2 times whatever x is. It's exactly the same in chemistry. Okay, key thing here, do not change subscripts. That's all caps. Okay, so think about this. Okay, so you're working with oxygen, and you're trying to balance this equation, and you're like, well, I need one more oxygen. Why not? Okay, so you're like, okay, so I have 2 irons here. I need 2 irons here. I have 3 oxygens here. If I was going to get 3 here, I'm just going to change this into a 3. Okay, we cannot do that. This is oxygen gas that we breathe, and this is something totally different, ozone. Okay, so again, if you change the subscript, you're changing the substance's identity. Okay, we don't want to change the substance's identity, we just want to change how many we have. Okay, so this would change the substance itself, not how many. We want to change how many. Okay, and this would be a bigger deal if we had more time like we usually do. I'm going to always give you these, but before balancing, you want to make sure all your chemical formulas are correct. Alright, so, I promised you a picture. Here's my picture. Okay, so I have the reaction arrow, okay, and you could think of The left side of the arrow is before and the right side is after. So this is the stuff that we have going into the reaction, and this is the stuff that we have coming out of the reaction that we're making. So we have the reactants on the left, the products on the right. This is in color if you look at the document on the computer. But basically, so we have one carbon, right? This is CH4, so this is a carbon, and then we have hydrogen, 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 hydrogen. Okay, and this is 2, right? There's our coefficient is the number out front. We have 2 O2 molecules. We have oxygen, 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 oxygen. Okay, over here we have carbon dioxide, CO2, so this must be our carbon, oxygen, oxygen. And then we have 2 waters. See, there's 2 of them. There's one, there's one. So we have oxygen, hydrogen, hydrogen, oxygen, hydrogen, hydrogen. Okay, so this one is already balanced. Okay, on this side that I can see here, if I count the carbons, I have 1. And then if I look at this side, if I count carbons, I have 1. That balances. Okay, if I look at oxygens, I have 1, 2, 3, 4, and I have 1, 2, 3, 4. Okay, they're kind of spread out all over the place. There's some here and some here, but it's still, I have 4 oxygens. I have 4 oxygens. Okay, hydrogens, I have 1, 2, 3, 4. And water, hydrogens over here, I have 1, 2, 3, 4. Okay, so since each element has the same number on this side as it's on this side, it's balanced. Okay, and we needed those 2's to accomplish that. Okay, if those 2's weren't there, then that molecule wouldn't be there. I just have 1 oxygen and 1 water, and now things aren't correct. Okay, on the left side I have 2 oxygens, and on the right side I would have 3, so they're not balanced. Okay, hydrogens would also be wrong. I'd have 4, oh boy, hydrogens over here. Hopefully that didn't freeze. Whew, sorry about that, my computer is about to die. So, again, we need those coefficients to make sure it doesn't seem like we magically have more or less elements as the reaction happens. Okay, so here's our best in my instructions. Write it unbalanced. Get a count of how many atoms you have on each side. And then this is going to be one of those things that gets easier and easier with practice. Okay, again, for emphasis, never change subscripts. That's changing the substance. We can't do that. And then update and double check. So we've got some practice here. I'm going to zoom in just a little more. All right. So we have barium sulfate plus carbon yields barium sulfide plus carbon monoxide. And again, we would have had a lot more time to practice that. I really like to start with just a straight vertical line right under my arrow to kind of keep the left side and the right side separate. So I have some elements here. I have barium, sulfur, oxygen, and carbon. Okay, and you're looking at the whole side, not just this first element, the whole side. And I like to write them in the same order over here. It just gets easier to compare. So I have how many bariums? Just 1. Sulfurs, 1. Oxygens, 4. Carbons, 1. On this side, I have 1 barium, 1 sulfur, 1 carbon, and 1 oxygen. Okay, so written as is, right now, bariums, sulfurs are both okay, carbon's okay, but oxygen I have 4 over here, and I only have 1 over here. Okay, so I need to put a coefficient out here that would make me have 4 oxygens. Okay, so you're going to take your coefficient is what you would multiply by to get the number you want. So I want 4 oxygen, so right now there's 1, right? So what I need to take 1 by times to get to 4? 4. Right, so that gives me 4 times 1 carbon, 4 carbons, and also 4 times 1 oxygen, 4 oxygens. So now oxygens are good, I have 4 and 4, but carbons got messed up. Right, so I need to fix that. So I have 4 carbons here. Well, what I need to put here to get 4 carbons? Well, I would need 4 times my 1 carbon, 4 carbons. Okay, so to balance this equation, I need no coefficient here because I just need the 1. If you feel better and really want to write a 1 there, that's fine, but you don't need to. 4 carbons would yield 1 barium sulfide and 4 carbon monoxides. Alright, let's try another one here. Again, I like to draw that line straight down from the arrow just to kind of keep things straight. And then I'm going to make a place to keep track of all my elements. And here's one. That's not one element, but that's one ion. Right? This is nitrate. One of those polyatomic ions. So he's going to stay together. So I'm counting how many of those I have. Alright, so on the reactant side, looks like I have 1 magnesium, 2 chlorines, 1 silver, and 1 nitrate. Okay, remember that 3 is part of what nitrate is, so that's 1 nitrate. Right on this side, it looks like I have 1 magnesium, 2 nitrates, 1 silver, and 1 chlorine. So I'm looking for what doesn't agree from reactant side to product. So I have 1 and 1. Looks like I need twice as many chlorines. So what would I put over here to give me twice as many chlorines? Well, I would put a 2 here. 2 times 1 would give me 2 of those, and 2 times 1 chlorine would give me 2 of those. Okay, so now 1 and 1 is good, 2 and 2 is good. Now I'm out of balance here. I have 1 silver and 2 silvers. So I need twice as many of this substance. It would be 2 times 1 silver is 2 silvers. 2 times 1 nitrate is 2 nitrates. And now 1s, 2s, 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 everything balances. Okay? Alright. Let's try this one. It says water breaks down into hydrogen gas and oxygen gas when electricity is through it. Okay, so we have to know a few things here to be able to go. So water we know is H2O. Okay, it says breaks down, so that's the reaction. It breaks down into hydrogen gas and oxygen gas. Okay, from the last chapter we learned hydrogen's never alone like this and oxygen's never alone like this. They're always diatomic, so it'd be H2 and O2. Alright, so there we go, we're ready. So we have only 2 elements to keep track of on this one. On the reactant side, looks like I have 2 hydrogens, 1 oxygen. On the product side, I have 2 hydrogens, 2 oxygens. This doesn't work, right? My hydrogens look okay. Looks like I need twice as many oxygens on the left, so I need 2 waters. Remember, you can't put a 2 there. That changes what it is. So I need 2 waters. 2 times 2 would give me 4 hydrogens. 2 times 1, 2 oxygens. So now oxygens look good, but I have 4 hydrogens here and only 2 here, so I need twice as many. So I need twice as many, so I put a 2 there. Now 2 times 2 would give me 4 hydrogens. So now I have 4s, 2s, and we balance. Alright, here we go. We got another one. Potassium iodide, which would be Ki, reacts with sodium to make potassium metal, so that'd be just plain potassium, plus sodium oxide. Okay, and there's 2 sodiums, because I know sodium's +1 and oxygen's -2, and then I crisscross, and that'd be sodium oxide. Alright, so I split my 2 sides. I have 3 elements to keep track of this time. Oops. Oh yeah, this was a mistake from last year. Forget this one. That doesn't make sense because I have iodide and then oxide. So that was my bad. Lucky you. Alright. This one we have aluminum, oxygen, calcium, and fluorine. Again, I think it's wise to put them in the same order on both sides. I have 2 aluminums, 3 oxygens, 1 calcium, 1 fluoride. How many aluminums? 1 oxygen, 1 calcium, 3 fluorides. Okay, So this one's got a mess of problems already to start with. Okay, I need twice as many aluminums over here. Okay, for sure. So I'm going to start there. Twice as many aluminums, so I put a 2 there. That would give me the 2 aluminums, but it also would give me twice as many fluorines. So I have 3, I have 2 times 3, so that gives me 6 fluorines. Alright, I have 3 oxygens over here, only 1, so I need 3 times as many over here. So if I put a 3 there, that would give me 3 calciums and 3 oxygens. Okay, so now I have 2's agree, 3's agree. Looks like I have a 3 calciums, so I need 3 times as many of that one. So I need a 3 there. 3 calciums, 3 fluorines. Uh-oh. Hopefully I didn't mess up again. Oh, I totally did. This substance should be CaF2. So 3 times 2 gives us 6 fluorines there. Now everything should balance. Alright, last one. Mg and O, magnesium and oxygen. Looks like I have 1 and 2, 1 and 1. So I am fine on magnesiums. I need twice as many oxygens on the right, so I put a 2 there, but that gives me 2 of both of those. Okay, so now these are good. I need twice as many magnesiums on the left, so I put a 2 right there. Okay. This is something that usually we spend days and days practicing. So tomorrow you have a interactive where you get to practice this kind of online, and the next day you'll have a normal worksheet about it, and that will basically be our year. So as always, let me know if you need any help. See you later.